Hello, my name is John, and this is
And I'm Jonathan.
Jonathan, and today we're going to be talking about highly available Postgres clusters in Kubernetes. A little bit about me first. I've been working with Kubernetes for 5 years. I started at my previous job on an infrastructure team, and they split that out from like traditional infrastructure to create a new Kubernetes team, and I was a part of that. Managing production OpenShift clusters. So I did that for 4 years. And then last year, I joined EDB to work on Kubernetes and Postgres, which seemed to be, a pretty cool challenge. And it turns out it is a ton of fun. I do Golang by day, working on the cloud native Postgres operator. And then I'm like learning Rails at night, which I get made fun of a lot for that, but Rails is fine. So.
And I'm Jonathan. Yes, I'm a San Francisco Giants fan, so yeah, that already you realize already. I'm not handsome, but sometimes I really like to have fun, so that's why I'm probably the funny one here, not like John. I'm on the Kubernetes World Science 2019, working second quadrants, just for work, 2 years before I started with Kubernetes, obviously trying. And starting on second quadrant was joining just on a PostgreSQL stuff. So now I'm starting to love PostgreSQL almost every day. Well, sometimes I really hate it, but it's databases. And working on computer science 2003, yes, I'm a bit old.
So CloudNativePG is a fully open sourced Kubernetes operator for managing Postgres. It was originally created by EDB, which is the company that we both work for. EDB is a company that has the most PostgreSQL contributors of any single company. So we have extensive Postgres knowledge in the company, and we're bringing that to the cloud native world through CMPG.
Okay, one of the things our talk is going to be explain how basically the operator works and how it's doing the work under the hood. And we will have a little bit of a demo, something pre-recorded with Askinema because, networking always producing some issues. And first you need to know, obviously, we are in a Kubernetes conference that on Kubernetes, so you know how to apply YAML files on the cluster. We are just going to use the standard kubectl commands, just get, delete, probably edit. Sometimes, yeah, we need to use edit. We will explain how our pod and our PVC are created. Probably you will have some questions. We are going to explain you how that starts. And, well, if you don't know what PostgreSQL is, well, probably you should not be here or you will learn.
Okay, so what do we mean by highly available PostgreSQL? We mean that we need enough PostgreSQL nodes to have quorum in case of a disagreement. So that the minimum number for that, as I'm sure you all know, is 3. Being on Kubernetes doesn't necessarily mean that everything is highly available. Just running on, you can't just run it on Kubernetes and then be like, oh, it's highly available. So what we mean, so we'll talk more about that. And storage is important. Our operator is storage agnostic, so we can work on whatever storage you currently have configured. There are storages that we would prefer and would not prefer, like would not prefer NFS, but if your Kubernetes cluster has the storage class, the operator will run on it. No, we do not use stateful sets, and this is a very important point in our operator design. It's something that might confuse you if you're new to using the operator. There are a lot of reasons we had for not going with stateful sets, primarily being like the ordering of how you want to bring up, how you would want to roll nodes is different depending on the operation you would use to start rolling out the nodes. So some changes you might need to start a replica first and then switch over, and then other changes you might need to restart the primary first. So because of that, we have our own controller to handle the spawning of Postgres instances. We do not use the stateful set controller. So that's an important point. That could be its own talk probably.
Yeah, you will have some questions about it. Okay, we decided our operator in 2019. We started with a really small team, just 3-4 of us. And we decided to rely everything on the Kubernetes API. That's a really important point right now. And actually, the talk that I don't know, it's not here. He already left about cloud native database. That's really important. And using the Kubernetes API and rely on it to be the single source of truth, it's actually really important, especially if you are in the Kubernetes, because you will have your application and your database will have the same single source of truth. Now, CloudNativePG is fully open source. We open sourced it this year in May. Yeah, in May, at the beginning of the KubeCon Valencia. It was actually really nice for us. We were looking for that for a long time, to be honest. And one of the greatest things in our operator is the failover. Automatically performs fast failovers. It's an important point. If you have been working with PostgreSQL, you know that the failover is actually not something so trivial. It's it could be really difficult. And also, we have been working on adding replication slots. Actually, this came from the last KubeCon in Valencia. So a lot of people started suggesting, hey, you should add the replication slot. Yes, we know we should. Do it. Okay. Now we have replication slots. It's really solid in the latest version. We are supporting our version, the versions of Kubernetes 122 to 124. Actually, 125 is also supported, but the reason that we haven't said that yet is because we are going to say it with the next release, which is 1.18. But it has been tested there anyway. And our latest version, we wrote this, it was 117.1. We planned to release 118.0 this week, but KubeCon, half of the team is here, the other half is on the other way. Coordinate, not possible, so we are delaying the release for the next week.
Okay, so we have a demo coming up after this, after we're done talking. So the proposed architecture for the demo, what we're going to create is what's known as a cluster object. And a cluster is it's an extension to the API added by the CMPG operator. And when we create the cluster, I'll say we're creating the cluster will be one primary and two replicas. When we create the cluster, the operator will create pods, PVCs, services, secrets, PDBs, and config maps. The pods will be the actual instances running Postgres. The PVCs, of course, for the data. The services will be for things such as connecting, of course. So like if you want to connect to your Postgres instance through a connection string, you can do it through the service. A metrics endpoint. Secrets for the password for the users. Pod disruption budgets to configure so the pods can't all be in the on the same don't all go down in a way that could cause corruption, and a config map for, of course, configuration. The cluster is not the only extension to the API that CMPG adds. There are, of course, backups, for example, and poolers as well. Backups are very easy to configure. I remember somebody in a previous talk said a Postgres operator has to have easy to configure backups. They are easy to configure. We're just not covering that in this talk. So,
yeah, well, literally stop talking. One of the things is that how to install the operator. That's one of the questions that everyone needs to answer. Okay, that's quite easy, and that's how we design it. Just apply one YAML file. The YAML file that you will actually need is the one in the release page on GitHub. It's just kubectl apply and the URL, and that will work. And if it doesn't, please tell us. We are on Slack all the day, 24/7 mostly. So when we apply this spec, we can go and start doing the demo. And you're going to take over the keyboard, right?
yes.
Okay. Okay, so we apply the YAML file, and let's do this. Yeah. Okay, we have an internal script which is set up cluster.sh. You can go into the repo and we'll create basically the kind cluster. It will compile the operator. There's load helper images. It's an additional exception function that we add in this script, which is basically to add images that we will require for some testing or even to run the operator. As you can see, it's loaded in PostgreSQL, PG bouncer, HTTP, min.io, that actually we use for testing. Okay, this is the same script that you can use for test locally or run the end-to-end test. And at the end, it deploys the operator, obviously, just a YAML file, as I said, the manifest. And right away, you can start creating the cluster, which is one job, the initdb job, and then creates the first pod. And there's the other jobs are join jobs that, as you can guess, is to join the next pod into the cluster. And we have a nice command that is kubectl cnpg. Probably you can reduce the size of the font. No, you cannot. Okay, this doesn't matter. And where you have information on the kubectl cnpg plugin, we try to provide go up a little bit. A lot of information on this plugin because, yeah, you are managing a database and your data is there, so you need to know almost everything. So you will know which one is the primary, the standby, the kind of replication, which in this case is async. Yeah, in the standby and everything. But the important thing here is what can we do with the operator? Okay, we can edit the cluster just like kubectl edit. That's where the kubectl commands are important. And go down and, for example, we can go. You will see that the configuration. There's a lot of things here. You will see the initdb because probably sometimes people will want to use a different. Encoding the database, the initial database will be up, the images that you have there, and there's a lot of things. And this one is important too, the monitoring stuff. The operator has inside a Prometheus exporter compatible, a Prometheus exporter basically. We expose the port, and you can actually just query any of the pods asking for a lot of information that we provide by default, which is basically a big set of queries that is running inside the cluster. One are running only on the primary server, and others are running on the replicas only, and some running on all of them. And one of the interesting things that you can do, and this is, when you're working with Postgres, this is one of the more complicated things that we were doing, and I learned this in the hard way, which is the synchronous replication. Basically, you have one query that gets inside the primary and only will return and say that it was successfully when it's replicated to, in this case, is a minimum of one. Yeah, when it's replicated to one of the replicas, okay? So let's apply it, and that's it. Can you run the kubectl status? CNPG status. There's and you can see that the quorum already changed. Now it's not async, it's quorum, meaning that we have asynchronous replication there. And that is kind of one of the hardest things when you are doing the basic PostgreSQL. Okay, but how hard is to do some other stuff like replication slots? Replication slots are really complicated at the end of the day, and we know that. Well, we implemented this a month ago, but sadly, the talk is a bit shorter, but can you open the file, the cluster YAML file? And we are not able because we are almost running out of time, but it's just that you can, there you go. Replication slot, high availability, enable true. And that will enable your replication slot. What's the idea of replication slots? Signs. One of the things that when you are replicating, you can rely on the WAL files, but the WAL files, at some point, you may have problem with the storage, and that happens, especially if you are using NFS or something like that. So this will allow Postgres to stream everything directly to the other replicas, and you will not be losing data. There's some more on documentation on this one. Can you go back to the slides? Next slide. There you go. First of all, we're hiding. We're about to close because we're running out of time. We're hiding. We're looking for Go developers and with operator knowledge. And that's important, the operator side. The Go probably you can learn, but the operator is really important. And that is totally agree on. You build it and you own it. We work as a team, and all the members here is owning the thing that is doing. Like my man here is working with some support on Velero and stuff like that. And it's great. He needs to write documentation today, by the way. And loves to play in a global team. And finally, but not least, thank you very much. And this is the site to get the operator. CloudNativePG if you can, please give us 1 star on GitHub. It's really nice. So that's it. Any question? Thank you.
All right, let's give it a star and give it a round of applause. All right.